And the first one is the 74157. That's a quad 2 input mux. Quad because there's 4 of them. 1, 2, 3, 4. 2 inputs. Each of them has 2 inputs, an A input and a B input. Okay, so quad 2 input mux, and just like every multiplexer, single output. And that's the 1Y, 2Y, 3Y, 4Y. And now this has 2 inputs. So 2 inputs only needs one data selection bit. So each one of these data select bits is tied to a single data select. Okay, so for a high on that single data select, it's the B inputs go to Y. Low, A goes to Y. Okay. Now there's also an active low enable. And basically, when 0, the chip is enabled. When 1, it's disabled. Okay. Next one you guys will probably run across is the 74151, which is an 8 input mux. So if there's 8 ins, if these guys are 8 ins right there, how many data select positions would you need? Well, probably 3 bits, because 0, 0, 0, all the way to 1, 1, 1, 1. That gives you positions from 0 to 7. So S0, S1, S2, those are data select bits, and this is D0 through D7. There's an active low enable here, and that's our output Y. And even though every multiplexer on Earth has only one output, this one has a bonus output, and that's called not Y. Basically, it'll just invert the data selected. Okay. So now the 74151, like I said, is an 8 input mux. But let's say you get 16 bits that you want to, 16 data sources that you want to switch from. Well, basically what you can do is a second 74151 in conjunction to form a 16-bit multiplexer where the enable forms the 4th selection bit. So here's the first 3 selection bits right there, but the enable can form the 4th one. And how you do that is just tie your enables together with an inverter in between. Okay? So remember, it's an active low enable. So when this guy is a 0 right here, it's coming in here, it hits here, this guy is enabled. This guy turns into a 1, disabled. Now, when that 4th selection bit comes in, the fourth data select bit comes in as a 1, it's coming in a 1 here, this guy's disabled. 0 there because it's an active low. This guy is enabled. And how you would tie that together is just do an OR in between. Okay? So you can make 16-bit multiplexer using 2 of these guys. All right, applications for multiplexers, unlimited. One that you might be more familiar with, though, if you remember way back when in EET 111, 112, 113, remember the BK Precision multimeter and how they had like a bunch of different modes that you always would get stuck in using the wrong mode. And I'd be like, dudes, come on, don't measure AC voltage using DC ammeter. Remember those things off to the side? These guys right here. And I had a single button next to each one, and that would make it like, say you pressed here AC ammeter, and now that display would read AC amps, and then you would go ahead and uncheck that one and put it to ohms, and it would show you ohms there. But notice how each one of these didn't have a display next to it. That'd be pretty costly and wasteful. You'd have like 6 different displays, but why not just use the same display? Well, that's what display multiplexing, one aspect of display multiplexing is you're using the same display for a number of different functions here. This right here, that's your data select. It's a single, and you're using let's just use a single 7-segment display, just to make it a little bit easier. And so here is our single 7-segment display: A, B, C, D, E, F, and G. And what is the chip with the active low outs? That is the BCD to 7-segment decoder. Well, it's a 7447, so you put that guy right there next to it. 7447, they're active lows. And you hook those guys up like so. And now what you do, all you do is just use a 74157, which, if you remember right, up here, which is our quad 2 input mux right here, this guy, and hook that up to the 7447, excuse me. Okay, and there's our 74157 right there. And by the way, I'm switching between 2 different applications here, not all 6 of these. We'd be here all day. So let's go ahead and get rid of those. Okay, so here's our 2 4-bit numbers that are coming in, our A number and our B number. A's get fed to the A's, B's get fed to the B's in parallel. Now you go ahead and just put a 0 on your data select, and each one of these guys are tied together, and that 0 is going to make the A come through. And what you're going to do is just tie your outputs to the multiplexers, the 1, 2, 4, and 8 weight of the 7447 BCD to 7-segment decoder. Now what's happening is basically all the A's going through the multiplexer, going into the 7447, and it's lighting up on the 7-segment display. So let's say A happened to be 0, 0, 1, 0. So there's our 2. And now B, 0, 0, 1, 1. So it would be a 3, but it's not being displayed. All of a sudden we switch our data selector to 1s, and now our B's are going through our multiplexers, and they're getting the 1, 2, 4, and 8 weight positions on the BCD to 7-segment decoder. And what it's going to do, it's going to show us a 3 rather than a 2, saving you all that weight of having all those displays. Okay, so again, multiplexers influenced by time. As we go forward, a lot of these things that we're going to be working on, especially when we get to memory and registers, everything's going to be influenced by time. It's sequential. Is that a 3? Yeah. Digital 3? Okay, good. I was getting dyslexic there for a little bit. Okay, let's move on.